not remember what things mean. That never happens. Ever. So when you get going into these, what you've got to remember is obviously you have a triangle. And when you have the triangle, your areas won't have base times height. Well, in order to figure out the base and height, that's where everything is perpendicular to each other. So you know that your vertical is the 12, but the base is just the 14. This part here is just to distract you from the correct answer. So your base times height is going to be 1/2 12 by 14, otherwise known as, what's that, 84 something squared? Okay. Very common. Oh, excuse me. It's a trapezoid. Which means you have to use a formula. Boy, if I only knew what the formula was, or where to find it. 1/2 the height times the sum of the bases. Yay! 1/2 of 7 times 9 plus 14. I was looking at the wrong problem. I was seeing if you were paying attention. I am talking like a moron. And not all of your answers will always be 84 square inches. Sometimes it'll be 6. Correct, because it might not be an area problem. So we getting that? Next one, we've got a rhombus, and no, it's a 7, not an O. This is an O. That's a 7. Just gonna throw it at you. So does it pay attention? Rhombus. When you have a rhombus, you have to remember parts of what things mean. Bless you. Obviously, when you have a rhombus, all sides are the same. But remember, the diagonals are perpendicular to each other, and the diagonals will bisect each other. That's where you get your 8s here. You have 17 here, which means you got to figure out what this length is. Gee, I wonder what you're going to use to figure out the length of something. Hey, what trig function do I use? Well, there's only 3 of them. You've already said 2, so what's left? What? Whatever. So use Pythagorean theorem, you're going to get 15, which means this part's 15. Area of the rhombus, 1/2 diagonal times diagonal. Put all that together, and I believe you get 120 something squared. Not 120, that's wrong. It's 240. Sorry, I looked at the wrong one. Sorry about that. I looked at the wrong problem. Number 4 is a what? And how do you find the area of a parallelogram? So what is 8 times 4? You are so SMRT. What? What did you do? What did you try to spell? Huh? What were you trying to do? I'm sorry, please help me. Right here, yeah. Yep. Yep. You got all four sides there. It's what? The what? So 4, guys, 4, you got a parallelogram. So it's 4 times 8. Hexagon. Boy, we've done a lot of these. Side of 10. Apothem bisects. Perpendicular bisector. Draw the radius. Bring the angle out. Once again, to find that exterior angle, that outside angle, we take 360 degrees, divide by the number of sides. This case is a hexagon, there were 6 sides. I'm no math major, but 360 degrees divided by 6 is 60. So if your outside angle is 60, the whole inside angle is 120. Remember the radius bisects it, and you get another 60-degree angle inside there. Now you've got a 30, 60, 90 triangle that you can use, or if you want to use trig to figure out the apothem, that's fine as well. If you use the 30, 60, 90, we know that across from the 30 is equal to 5, which means across from the 60 would be 5 root 3. Or if you use trig, you'd use the tangent of 60 is something over 5, and you're going to get the same result. Totally up to you. Remember, special right triangles will only work in the hexagon, because it's the only one that gives you a 30, 60, 90. That one, and I believe the dodecagon works, and the octagon gives you a 45 degree angle. So there's your apothem. How do you find the perimeter of an object? Yep. So you get 1/2, 6 sides of 10, and an apothem of 5 root 3. Multiply all that together, you should get 150 root 3 something squared, or whatever the decimal equivalent of that is. You always give like scrunchy pouty face when I do math. Well, you have the decimal of it. You do one, yeah, it's okay. Yeah, it's either it's 150. Okay, 150 root 3 something, or what was it, 259 point something, or 259 point whatever. Remember, the test itself, it'll probably give you the values in terms of radicals. It's usually how we've been doing stuff in class. So if your calculator doesn't do the simplified radical stuff, you'll just have to figure out which of the answers matches that just by pressing a couple buttons. Believe me, guys, there's plenty of time. It doesn't take very long. This we could probably don't think we're gonna need a full 75 minutes to get this one done. 703. But if you take 703 and you subtract a lot, you'll come up with 45. I think it's 45. Is that right? You know what? If it only said so on the front page of the review packet, was it there? It didn't even tell you, what type of questions there are that. But you know what? I will say one thing was wrong on the front page of that. Guess what was wrong on the front page? What semester is this? Second semester, not first semester. So, hey, why not have a typo? It's more fun. Way to get on board with that, Kleckner. I appreciate the enthusiasm. It does? Oh, the one earlier one said semester. And about it's worth it. All right, next one. We've got a composite figure. Yeah, that's pretty good. So you have this awesome looking composite figure. Which means we got to figure, the easiest way to do on this one is to draw it out of a rectangle and a triangle and do two separates. So you have a rectangle plus the area of a triangle. So we've got our rectangle here. It's 120 by 60. Okay. Now, I have to be able to figure out the other parts out of that now. Well, if the whole top part was 200, I back out the 60. That means this portion is going to be 140, I believe. And I do the same thing with the 120 and back out the 40. And that gives me an 80 here. Press a whole bunch of buttons. And I believe, if I remember correctly from a couple hours ago, 12800. Something squared. 12,800 meters, whatever it was. Hooray for math. Okay. It's close. Circles. Remember, you have all of the formulas in front of you, or nearby where you are sitting on that piece of paper that's very close. Trying to erase this. So when you go through these things, you just look at your formula sheet. Circumference. Circumference is 2 pi r. Well, in this case, it's 2 times 27 times pi, otherwise known as 54 pi. Arc length. Arc length, there is a formula for the thing called arc length, which means you have to use the formula for arc length. So look at the formula, and it says arc length is central angle over 360 times 2 pi r, which is the circumference. Well, your central angle is 40 over 360 times 54 pi. Well, you can do one of two things at this point. Use the fraction bar, type it all in, you get the answer. Or if you simplify, it works just as well. 0 drop, 4 goes into 360 9 times, 9 goes into 54 6, and you get 6 pi. Area of a circle. Boy, I wonder if there's a formula for the area of a circle. Sir. 54 pi. Area of a circle. I bet you all you have to do is square 27 and slap a pi next to it. And you're going to get 729 pi square centimeters. Wherever it was. And guess what? There's a formula for it. Which means you have to read the formula. Guess what? There's a formula for the area of a sector. Area of a sector is your central angle over 360 times the area of a circle. Once again, this simplifies out to be 1/9. This goes into here 81 times. Formula. Becky! Oh, Whiskey, get better hands. You dropped the ball. Hey, you want to see a trick? Here, let me show you a trick. I've been working on this the past few days. Oh, I'm sorry. So this is your... That's a little further away. I've been doing bank shots in the recycling bin. Oh, much better than I am, Whiskey. But we already do that. See what happens. I'm not gonna hit you. I say that now, you guys are like, no. That's no wonder why you want to sit in the corner. You don't have to worry about it. You don't get tired. Hey, good times. Area of the shaded region. Well, when I was drawing this one out a couple times with some yesterday, this one. If I draw this correctly, this should work. Perfect. Bam! Yep. It's the same question that's on the review packet. So this one here, if you go through this, the problem gives you a couple parts. You've got your 4 3s and an 8. Now, I'm no super awesome geometry person, but I realize that if I take this center piece out and I fold this in, what I just create, a triangle. How do you find the area of a triangle? 1/2 base times height. Well, if I go back to here, if the portion that I took out was 4, when I put it together, how much is the base then? 4. So you have 1/2, 4 by 3, otherwise known as 6. See? Told you collector 6 shows up. But then I got my units. Don't know why people tend to go on that problem. We did the circle one in class yesterday, didn't we? No? I thought we did. that looks cool. Yeah, that looks neat. I like that. It's fancy. I'm like an artiste. Maybe not. So according to the diagram, ladies and gentlemen, this is 3, and this is 2. We need to find the area of the shaded region. Well, the shaded region is created by a giant circle, subtract out 2 smaller circles. Well, the 2 smaller circles are easy to deal with. I have a 9 pi and a 4 pi for the 2 areas, because the radiuses are 3 and 2 respectively. But what I need to do is figure out the radius of the large one. Sir, what's the area? How do you find the area of a circle? So if I go through here, 2 plus 2 is, plus 3 is, which makes the whole diameter, which gives it a radius of, square it and you get, I wouldn't say it's crazy, it's just math. And you get, what, 12 pi something squared? What's 2 times 2? What's 2 squared? Okay. It just so happens that with the number 2, 2 plus 2 is the same as 2 times 2. When you square something, you're multiplying it by itself. So 2 squared is 2 times 2. Just so happens to be the exact same answer as 2 plus 2. It's called what we like to call it a coincidence. Well, it's like the quote we had from earlier in the day. It's just my last 2 brain cells talking to each other. I thought it was pretty good. Or a calculator. You have a calculator, right? Use it. Geometric probability. Shading. Geometric probability means find the probability of the shaded region divided by the total area. Not probability, area of the shaded region. So in this one, your shaded region is again going to be a triangle. And if I back out the middle portion, I'm going to have a base of 6, a height of 3. So the shaded region, the area of the shaded is going to be 1/2 6 times 3, which is equal to 9. Okay. And then the overall, the area of the whole thing, is a trapezoid, so it's 1/2 the height, sum of the bases. So when I put that together, I get, what is that? 18, half that 9, 27. So I take 9 divided by 27, I get 1/3. And that's the geometric probability of landing within the shaded region. Make sure you guys are awake. Next one, we have a circle cut out of a trapezoid, or excuse me, out of a parallelogram. So we have to take the area of the parallelogram, subtract the area of the circle, divided by the area of the parallelogram. Well, area of parallelogram is just base times height, so 6 by 11. So 6 times 11 is, it gives us a diameter of 4. So if the diameter is 4, the radius is 2. When I square 2 collector, what do I get? And then I slap a pi next to it, so it becomes 66 minus 4 pi divided by 66. Now, here you have to make sure you do this correctly in the calculator. So when you type this in, you have to use the fraction bar, otherwise you're going to screw something up. So we've got, you make a fraction bar real quick, 66 subtract 4 pi over 66. And your answer should be less than 1, because if it's more than 1, you've done goofed. If it's negative, you've done goofed. If it's negative more than 1, or negative less than 1, or basically negative, you've done goofed. It's loud, it's fun. Make sure you're awake. Ratios of sides. So when we did ratios of sides, we did it this way. We had ratios of the sides, and then we had scale factor. Then we had area ratio, which led to volume ratio. And as we went through the process for setting those up, what we did was we would say that the ratios of the sides were in the fraction form of A to B, which therefore gave us a scale factor of A to B, which then gave you an area ratio of A squared, B squared, very good, which then gave you a volume ratio of, depending upon what information you had is what you started with, and simplified fractions and worked forward and backwards depending upon the problem. Well, the first one, it says you have the ratio of the side leads to two similar polygons are 5 and 8. The ratio of the smaller polygon, or if the area of the smaller is 125, on the area of the larger. So they're giving you ratios of the sides of 5 to 8, which means the scale factor is 5 to 8, which means the area ratio would be 5 squared over 8 squared, which is 5 over 64. Now I have a working ratio that I can work with. You know, you got 2 days left. If you want to move so you can see them, it's fine. We now have a working ratio to find the missing side or missing area. We know that the one of them was 125, because I think it's at the smaller of the two, which means it has to go to the numerator. And then you just cross multiply to solve out. I think it was 320. Does that sound right? Because 5 times 25 is 125. 5 times 64 should be 320. Is it 320? So the answer here would have been 320 something squared. I forgot what the units were. But I do want to mention here on 16 there was a typo. Sorry, it wasn't me. I didn't do it. They give you the areas, but notice the units they gave you. They gave you units cubed. Those should have been units squared. Okay, for number 16, those should be units squared. So in that one, you're starting with areas of 27 and 147. So if I'm starting with areas of 27 and 147, that means I'm going to put those underneath my area ratio. So what I do now is I need to figure out the working area ratio so that way I can go and figure out side lengths. So all I have to do is put that in my calculator. what was it, 27 over 147? Thank you. And hit enter, and it'll automatically simplify that for you. So you don't have to math it. Okay? It's nice. So right away I know that I have a working ratio of 9 over 49. I need to figure out side lengths. So I need to work this direction. So what do I do to that area ratio to get to the side length ratio? Square root it, good. So when I square root 9 over 49, remember, your calculator will do that. Since I just simplified it, all I have to do is second square root of my answer and hit enter, and I'll get 3/7. That gives me a working side ratio to go with. So I have 3/7 has to equal, well, they gave us the larger polygon is 35, so the larger of these two numbers, again, it's tough to figure out, is 7. Whew. 7 times what is 35? 5 times 3 is? There's your answer. Obviously, you can cross multiply, so we work out just fine. A lot of times when you get numbers that are that clean, it's kind of nice just to do it that way. Reminder, as you get into areas, or into the surface area stuff, as you start looking at all those formulas and whatnot, I had a lot of discussion with kids second art because they all kind of forgot how to read. That was hard. But when you're dealing with your volume formulas, for example, or surface area, you got area of the base plus 1/2 the perimeter times the slant height. Remember, big B is the area of a base, which means you have to look and figure out what the base is. The base is the one that has exactly 2 of if it's a pyramid, or excuse me, a prism. It's the one that has exactly 1 of if it's a pyramid. The p-value is the perimeter. And how do you find the perimeter? Well, you add up all of the side lengths of the base. And then that L was the slant height. Okay. Again, they're not going to be all that difficult. What I'll do tomorrow is I'll run through area stuff, and then I'm going to talk, or surface area and volumes, and then I'm going to look at your old Chapter 10 and Chapter 11 tests with you guys to go over a couple of questions that I know that most of you guys screwed up. So if you have those still with you, great. If not, just make sure you have paper so we can revisit a few things that I kind of have a feeling that may or may not show up once again. Sounds like a good time. Let's maybe do it one more time. A little further away. Well, I missed. So you guys really did that whole year with like 5 of you? That's awesome. Seriously, that's damn impressive. Good for you guys. That's really, really cool. Remind me, like, well, we only have 2 days. I'll bring you in so you can laugh at the production value of